Hey guys, we're back again today working on multiplying our rational expressions today. The last video we talked about was simplifying, so you just had a single fraction and we worked to simplify it. Today we're going to have at least two fractions, could be more, but we are multiplying them. Notice your steps here are very similar. You're still going to factor first, and that's every top, every bottom that you can. You will do your restrictions, which is just based on your denominator. Right, restrictions is denominator only, and that is where we set them not equal to 0 and then solve them. Then you're going to cancel, and then the last step, step 4, is smoosh. I know that's a really weird way to say that. I didn't want to write multiply because sometimes you multiply, but most times you really don't. And I know that gets very confusing. What I mean is if you were left with like an x, oh my goodness, x plus 2 and like an x minus 3, I don't want you to distribute those all back together, right? I want you to leave it in factored form. So this, like, you would leave that. Now, if you had a 4x left on one and a 3 left on the other fraction, I don't know, let's put a 1 here and let's make that 2/3. And I asked you, you got to step 4, which says to smoosh. You would just actually, on the top, you'd have a 1 and a 2. 1 times 2 is 2, and on the bottom, 4x times 3 would be 12x. So you would multiply those, but the big idea is I say smoosh because I don't want you to actually distribute like your polynomials back together. Because in order for these to be considered simplified, everything is actually in factored form. Okay? All right, so let's kind of take a look. I think we have 6 examples today, and then we'll go. All right, so here we go. Problem number 1. Step 1 is to factor. Now, when it says factor, you are going to factor every top and bottom that you possibly can. So on the top, I can factor that one. That will factor to an x plus 3 and x minus 2. The bottom is just a single term, so it does not factor. It's just 2x squared. The next fraction on the top, I can take out a 2. Don't forget to look for those GCFs. And on the bottom, that will factor to an x plus 4 and an x plus 3. All right, so I did step 1. I factored everything I possibly could. Step 2 is my restrictions. I'll put them over here off to the side. Now, the restrictions come from every bottom piece, every denominator. So you're going to have 2x squared cannot be 0. You're going to have x plus 4 cannot be 0. And you have an x plus 3 cannot be 0. Restrictions are the denominators, the bottoms of the fraction only. All right, so solving the first one, you can divide by 2, take the square root, so you find out x cannot be 0. On this one, you would have x cannot equal negative 4. And your restriction here, x cannot be negative 3. All right. The next step is to cancel. And now I have 2 fractions, but when I cancel fractions, any top, any bottom, doesn't matter. Okay, as long as it's a top and a bottom together, you can cancel. So I have an x plus 4, those will cancel. I have an x plus 3 here and an x plus 3 there. And let's see, I have a 2, cancel with this 2, because they are not held with a plus or minus, so I can kind of break those apart to cancel them. So it looks like on top, all I have left is an x minus 2, and all I have left on the bottom is an x squared. Now notice I did not cancel out these x's in my answer. Okay, the reason I did not cancel those, the top one, x minus 2, is held with a minus sign, gluing it together with that 2, so I cannot break that apart. So that is as simplified as I can get. All right, number 2. Step 1 is to factor. So the top has a difference of squares, my favorite, x plus 3 and x minus 3. The bottom is just an x, right? That's just a monomial, nothing I can do. The top is just a 3x, and the bottom I can take out a 6 for my GCF, and I'm left with x plus 3. All right, step 2 is restrictions. So my denominators, I have x cannot be 0. That one's done. The next one, I have a 6. Remember, x marks the spot. Their baby brother on that case, he doesn't mean anything to me. So then I have an x plus 3, which cannot be 0. So x cannot be negative 3. All right, there's restrictions. All right, step 3 says to cancel. So any top, any bottom. I have an x plus 3 that can cancel. And I have an x here that cancels with this x down here. Keeping in mind when we're looking at these, if they're held with a plus or minus, they're glued together. If they're not, they're fair rein. You can break those apart. All right, and then I also have a 3 on the top and a 6 on the bottom. So I can divide those both by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. Now that's step 4 that says smoosh. Make sure you say it like that. Smoosh. It's kind of fun. No one's listening. Go ahead. Smoosh. Smoosh is fun to say. Anyway, what that means is kind of smoosh together everything on top and everything on the bottom. So on the top, all I have left is a 1 times x minus 3, which is just x minus 3. And on the bottom, all I have left is a 2. And we're done. All right, problem number 3. Step 1 says to factor. So factoring out the top, I can take out a 2 as my GCF. The bottom is my favorite, x plus 4, x minus 4. All right, the top of the next one, that would factor to x plus 4 and x plus 1. And the bottom, that's going to factor to x plus 4 and x plus 4. All right, next step are your restrictions. So your denominators, I have an x plus 4, which cannot equal 0. I have an x minus 4, which cannot equal 0. And then I have another x plus 4 and x plus 4. I already wrote that down. I don't need to solve that 3 times. So x cannot equal negative 4 if I solve that one. And x cannot equal positive 4. That is a terrible 4. There we go. All right, so those are my restrictions, plus and minus 4. All right, and then the third step says to cancel. So any top, any bottom. Now, when you are canceling tops and bottoms, make sure you're pairing them up and then canceling. All right, so I have an x minus 4 and an x minus 4. And then I have an x plus 4 and an x plus 4. You cannot cancel that with more x plus 4s. And then this x plus 4 and this one, they're both on the bottom, so they don't cancel each other out. All right, step 4 says to smoosh. So on the top, I have a 2 and I have an x plus 1. Do not distribute and multiply. We want it in factored form. And on the bottom, I have an x plus 4 and an x plus 4. And I am done. Now, if you're a lazy mathematician like I am, on the bottom, if you want to write that as x plus 4 squared, you can do that. Okay? So whichever way you want to write that is fine by me. All right, number 4. Directions. Let's see, step 1 says to factor. So on the top, we're going to have x minus 2 and x minus 1. The bottom actually does not factor. It's 2 terms, but I don't have an x squared, there's no GCF, there's nothing I can do with it. The top is a difference of squares, x plus 6 and x minus 6. And the bottom, be careful, that's that 6-5 combo I referenced in the simplifying section. Make sure you're careful on your signs here. You're going to have an x plus 6 and an x minus 1. Your last one's negative, so you have to have 1 plus, 1 minus. All right, next step is restrictions. So your denominators. So x plus 2 cannot be 0, which means x cannot equal negative 2. Hope you guys are okay here. I'm kind of taking my little shortcuts. X plus 6 cannot be 0, which means x cannot equal negative 6. and x minus 1 cannot be 0, which means x cannot equal positive 1. So those are all of my restrictions. If you need to write it out, that's fine. If you understand where those are coming from, you can take the little shortcut. You can even just list them in a row. I could have just said x cannot equal -2, -6, and, and 1. All right, so you could have just listed them that way too. All right, your next step is to cancel any top, any bottom. I see x plus 6 there, that can cancel. I see x minus 1, so that can cancel. And I think that's it. So smoosh it all together for the last step. On top, I have an x minus 2 and an x minus 6. Do not distribute those, leave it factored. And on the bottom, I have an x plus 2. Now the x minus 2 on the top does not cancel with the x plus 2. One's a minus, one's a plus. They are different. All right, number 5. Now this one looks a little different because we don't actually have a fraction. So to make anything a fraction, we know we just put it over 1. Now hopefully you've also noticed on this one that it is written in the wrong order. So make sure you're writing it in the correct order. To flip that around, that's actually -10x plus 15. All right, whatever sign's in front of it stays in front of it when I rewrite it in a different order. Okay? All right, so let's go ahead and dive right in. Step 1 is to factor. Nothing I can do with the 4. On the bottom, I can factor. So let's see, I'm going to have 2x and a 1x. And I'm going to have a 1 and a 3. That's going to be a minus, that's a plus. Yep, so that worked out. If you're not sure, take your time, work through that, check. All right, multiply and make sure you get the -1x in the middle. All right, on the top of the next one, I can take out a -5. Remember the rule, if you have a negative, your first term's negative, you need to take that out. I'm left with a 2x minus 3, and that's over 1. All right, looking at restrictions, your bottom, so 2x minus 3 cannot be 0, so that means x cannot be a positive 3 over 2. X plus 1 cannot be 0, so that means x cannot be -1. And x marks the spot that does not have an x, so that does not give us an additional restriction. Okay, only where x's are. All right, so there are my restrictions. And then step 3 says to cancel. So that's any top and any bottom. And I do have a 2x minus 3 on top and 1 on bottom. And unfortunately, it looks like that is it. So step 4 says to smoosh. But thinking back to the first page where we talked about this, if it's just plain old numbers, we want to go ahead and put those together. Now I have a 4 and a -5. Do not subtract those. See the sign in the middle of that dot right there, right? The dot in the original problem? That means multiply. So that gives me -20. And then on the bottom, all I have left is an x plus 1 times 1, which doesn't change anything. And I'm done. All right, so last problem for you guys. So again, this is over 1, if you're thinking about your fractions. Step 1 says to factor. So I can take a 3x from here, and I'm left with x plus 1. On the next one, I can take out a 2. I'm left with 3x plus 1. And on the bottom, we can factor that one. We're going to have 3x and x, 1 and 1, and they're both plus. So we can look at our restrictions. All right, that does not have an x, so that one does not give me a restriction. 3x plus 1 cannot be 0, which means x cannot equal a -1/3. X plus 1 cannot be 0, which means x cannot be -1. There's my restrictions. And then canceling anything on top and bottom, I have a 3x plus 1. I have x plus 1s. And all I have left on the top is a 3x times 2. Do not add. That gives me 6x and just a 1 on the bottom, which I don't really need. So I am done, 6x. Real quick, if you had a 1 on top and just the 6x on the bottom, does the 1 make a difference? And the answer is yes. Is 1/6 the same thing as 6? Do you want 1/6 of a pie or do you want 6 pies? If I'm hungry, I want 6 pies, right? You want more. So just be careful, all right? 1 on the bottom, dividing by 1 doesn't change anything. So 1 on the bottom, you can write it or not, it does not matter. If there's a 1 on the top, that, however, you have to write. All right, so that is it for today. Go ahead and work through the homework problems, check your answers, and then take the quiz when you are ready. If you guys have questions, make sure you ask.